this chapter, we're going to be going over 2.7, combining functions. So two functions, f and g, can be combined. We have different kinds of combinations. We have addition, subtraction, multiplication, and division. So, for example, for addition, we're going to have f plus g of x equals fx plus g of x. So there's a certain algebra to the way that it can combine these functions. So let f and g be functions with domain a and b. So our f plus g of x equals fx plus gx. And our domain is going to be the intersection of the domains of a and b. Our f minus g of x equals fx minus gx. Fgx equals fx times g of x, and then f over g of x is fx over g of x. So all of these are domain is going to be the intersection of a and b, but then for our division, we're going to have x in a and b, and then also we're going to have to exclude 0 from the denominator, so we don't want our g of x to equal 0. Alright, so for example, we have f of x equals 1 over x minus 2, and g of x equals square root x. So we're going to go ahead and find f plus g, f minus g, f times g, and f over g in their domains. Okay, so the domain of f of x is x such that x does not equal 2, because that's when the denominator would be 0. The domain of g of x is x such that x has to be greater than or equal to 0 because it's a square root. So our intersection of our domains is going to be x has to be greater than 0, and then x can't be 2. So we're just doing both domains combined. So really we could have 0 to 2, including 0, unioned with 2 to infinity, not including 2. Okay, so our f plus g of x is going to be fx plus gx. So that's just 1 over x minus 2 plus square root x. F minus g of x is our f of x, 1 over x minus 2 minus square root x. And then if we're multiplying them, we have fx times g of x, that's just square root x over x minus 2. And then f over g of x is 1 over x minus 2 times square root x. Because we're multiplying them, we have basically 1 over x minus 2 over square root x. And then when you multiply, you are doing basically 1 over x minus 2 times 1 over square root x, because the division. So that's how we get 1 over x minus 2 square root x. So in the domain of f of g, we have to exclude 0 from the original domain, because g of 0 or square root of 0 is 0, and then that was 0 at the denominator, so we can't have that. So now we update our domain to be x greater than 0 and x cannot equal 2. So then if we have f plus g, and we evaluate this at 4, this is going to be f of 4 plus g of 4. So we have 1 over 4 minus 2 plus square root of 4, and that is going to be, if we evaluate that, we have 1/2. Oh, sorry, not 1/2. We have 5 over 2. Okay, graphical addition. So f plus g is adding corresponding y coordinates. So if we have different functions and we're doing these algebra functions to it, really we're either adding, multiplying, or dividing by the corresponding y coordinates, because those are like our f of x and g of x's. So we have a composition of functions. So given two functions, f and g, our composite function, f of g, defined by, we have f of g of x equals f g of x. So we usually call this fog, or it's f of g of x. So basically, our g of x is like our y value for our g function. So we're evaluating our g of x, and then whatever that range value is, we're substituting that back into f to be our domain, or our x value for f, and then we evaluate. So it could also, we also have g of f of x, and that is g f of x. So it's the similar thing. So for example, we have f of x equals square root x, and g of x equals x squared plus 1. So if our h of x, if we have that equal to f of g of x, that's going to be f g of x equals f, and then we're plugging in our g of x, which is x squared plus 1. And so we have square root x squared plus 1. So this part is our g of x, and then our square root is our f of x part. So our x input, the original x input, goes into g, and then it comes out as x squared plus 1. We plug that into f as our x value, and then we get out x squared plus 1. So given f of g, we start with x in domain of g and find its image, or range, g of x. And then if that number, g of x, is in the domain of f, then we could calculate f of g of x. So f of g is f composed with g. So our f composed with g is defined when both g and x and f of g of x are defined. So our domain of a composite function, f composed with g, is a set of all x such that x is in the domain of g, and then g of x is in the domain of f. So if x isn't in the domain of g, that means that it cannot be in the domain of f of g. So for example, we have f of x equals 3x minus 4, and then we have gx equals x squared minus 2x plus 6. So for a, we're going to go ahead and find f composed with g of x. So we have f g of x equals 3. We're going to use this equation. So we have 3, and then our g of x gets substituted in for our x, minus 4. So go ahead and throw in the g. So throwing in that, we have 3 times x squared minus 2x plus 6 minus 4. We just distribute the 3 and then simplify. We get 3x squared minus 6x plus 14. So for b, we're doing g composed with f of x. So we're substituting our f of x into our x value for g of x. So our g is x squared, and we're plugging in f of x wherever we see an x. So we have fx minus 2 fx plus 6. So plug in our f of x is 3x minus 4 squared minus 2 times 3x minus 4 plus 6. And that simplifies to 9x squared minus 30x plus 30. And then an important thing to realize by evaluating a and b is that f composed with g of x does not equal g composed with f of x. So they're not the same thing. Alright, let's do g of f of x evaluated at 1. So I have g, and then the 1 goes into the x here. So we have g f of 1. So what's f of 1? So our f of 1 is 3 times 1 minus 4. So that's 3 minus 4 is negative 1. So now we are evaluating g. I'm going to erase that g and write it. G of negative 1. So now we're plugging in negative 1 here. And that's 9. Okay, here we have another example. We have f of x equals square root x, and then g of x equals square root 2 minus x. So we're going to do f composed of g of x. So we're plugging in, this is our g of x, and then we're plugging that into our f. So we have square root over square root of 2 minus x, because this square root is from our fx, and then this is from our g of x. So then to combine the square roots, we're just doing 1/2 times 1/2, which is 1/4. So that's why our square root is to the 4th. Okay, B is g composed with f of x. So we're going to plug in square root x to g. So then every time we see an x in our g of x, we're plugging in square root x. So it's square root 2 minus square root x. Our C, we're doing f of x. So we're plugging in f of x into itself. So f with square root x, and that's going to be every time we see an x, we do an x there. So that's going to be x to the 4th, the square root of 4. Alright, so for D, we're doing g of x. And so we have square root 2 minus x. We're plugging it into itself. So we're plugging this in for every x. So we have square root 2 minus square root 2 minus x. And then we're going to find the domains for all those. So our domain of A, which is the square root, but a 4th root of 2 minus x. So basically our 2 minus x just has to be greater than or equal to 0 because it's under the square root. So therefore, if we subtract 2 and then divide by -1, our x can be less than or equal to 2. And so our domain is -infinity to 2. So for B, we have our domain of 2 minus square root x has to be greater than or equal to 0. Therefore, our square root x can be less than or equal to 2 if we get the square root x by itself by subtracting 2 divided by -1. So therefore, our x can be less than or equal to 4, or we have 0 where x is between 0 and 4. So our domain is going to be 0 to 4. Alright, so our domain of f is just the cube root of 4. So it basically just has to be, our x has to be positive, so it's going to be 0 to infinity. And then for D, our 2 minus x has to be greater than or equal to 0. So that means that we're having 2 minus square root 2 minus x is greater than or equal to 0, because that's what's inside our square root. So our x has to be less than or equal to 2. So our 2 square root 2 minus x has to be less than or equal to 2. Or 2 minus x is less than or equal to 4. Or x is greater than or equal to -2. Therefore, -2, x is between -2 and 2. So our domain is going to be -2 to 2. And so if you got confused about the domains, I would just review our section 1.8 on inequalities, and then also just on what's allowed under square root. So our f, this example, we have fx equals the 4th root of x plus 9, and we want to find the f and g such that f equals f composed with g. So here we're splitting up a composition. So we could say that our g of x is x plus 9, And then our f of x is the fourth root of x. And we could test that. So let's see. We have our f composed of g of x. That's going to be 4. And then plugging in our g of x is 9. So that matches. So we're good. Okay, I'm going to do the next video on chapter 2.8 next time. So I'll see you then.